Okay, everyone, so what I need you to do is pull out your 5354. We did half of it on Wednesday, and we're going to finish this off. And then just do two other very short sections. They're very short. I'm just going to make 3 short videos on this stuff. Okay, and that'll be for Friday. I urge you to read the directions very carefully on the OWOW. I'll be sending you a message about it, about how you're going to have to contact me through Zoom room this week over spring break. And so I know that you can submit your OWOW through an iPhone or through an Android, because you're going to need to be able to send it to me as one PDF for the exam, which is also noted in the directions on that OWOW. It's super, super easy to do, so it's nothing to worry about. And we can talk about it face to face when we see each other on Zoom. So let's just review really fast what these terminologies are, because I'll be using them throughout this section. So the dividend is your starting value for your division, and your divisor is how many groups you're going to divide that into. All right? And the answer is always quotient. For any division problem, right, the result is always called the quotient. So I'm going to pop that in there right now into both of those bubbles, because the result of division is always a quotient. So if you're going to write a horizontal division problem in a fraction, the dividend, that first number, goes in the top of the fraction, which we also know is called the numerator. Okay? The divisor is going to go into the bottom of a fraction, which we also know is the denominator. And then if you're writing it out with this division symbol, the number that goes on the inside is the dividend, and the divisor is the number that goes on the outside. So just a little vocab review. And then the other piece to this is just to be able to look at a fraction and know if it's going to be greater than 1 or less than 1. And so I just wanted you to compare these to 2 or 1/2. Now look, if this is a proper fraction, you know it's got to be less than 1. So the result of 6 over 2 has got to be the 1/2. If it's written like this, I recommend that you write it as a fraction. So the first number, the number that goes in your numerator, is the number that's inside that division symbol. And the divisor, the number on the outside, goes in your denominator. And so again, you can see that that's a proper fraction, so it must equal to the 1/2. 16 over 8, if you want to or need to see that as a fraction, you can see that that's improper, so that's going to equal 2. And then the 7 over 14, right? If we rewrite that as a fraction, that's a proper fraction, so that's going to equal 1/2. All right. Now, I just want, before we hit number 1 and number 2, I want to talk about what division means. So if I have 8 divided by 2, this means how many groups of 2 can I get out of 8? So if this bar equals 8, this is 8 total, right? How many groups of 2? 2, 4, 6, 8. So I can get 4 groups of 2 out of 8. All right, if we do this on a number line, it's the same concept. So 1, 2, 3, 4, 5, 6, 7, 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. And you can see that there's 2. There's 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2. So 8 divided by 2 is 4. If I said 8 divided by 1, that's really saying how many groups of 1 can I get out of 8? Well, that's pretty obvious that without even thinking about it, I know that that's equal to 8. Now look, as the divisor gets smaller, do you see the quotients getting bigger? So let's do 8 divided by 0.5. 8 divided by 1/2. So how many halves can I get out of 8? Well, there's 0.5. right? So they're 1, 2. I'm going to cut all of these 1s in half. So how many 0.5s can I get out of 8? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I can get 16 halves out of 8. So that's really what division means. Like when you see this, you need to ask yourself, how many 0.5s can I get out of 8? That's really what division means. But what I hope that one thing that I want you to see, that as this divisor gets smaller, we're partitioning this into smaller pieces, so that means the quotient's going to be bigger because you're going to have more pieces. All right, so let's just look at this. So this is just a practical application. So if you and a friend went out for coffee and dessert and it came to $8.46, could you guys split it in two without needing a calculator? Well, you're going to think about it the way we just did. So 8 divided by 2, how many groups of 2 can I get out of 8? Well, 4. How many groups of 2 can I get out of 4? And how many groups of 2 can I get out of 6? So that's technically how you can think about it. But now this is a little bit harder, but this is what I want you to ask yourself. I don't care what it is right now. I just want you to ask yourself, will the answer to this question be bigger or smaller than that? Now remember, as the divisor gets smaller, the quotient gets bigger. So one thing that I do know is that this answer is going to be bigger than $4.23 because this quotient is smaller than 2. Okay? All right. So it says let's rewrite this division as an equivalent quotient where the divisor is a whole number. So I'm looking around for some scrap paper. I'm just going to do this on scrap. And then we're going to look at some rules on the next page and play with it, okay? So long division is only a bonus on your test, all right? Long division is a bonus. So I'm going to show you how to work with it right here. I'm using some scrap paper. All right, you ready? So we want to divide $8 or 8.46 divided by 0.2. Well, I'm letting you know right now, in order to do long division, this must be a whole number. The divisor must be a whole number. So we're going to rewrite it. So to rewrite this as a whole number, we're just going to do a decimal shift. So if I shift this one place to the right, I just have to remember I have to shift my dividend one place to the right. And then we can rewrite it. You ready? So this is going to be 2 for my divisor. Instead of 8.46, it's going to be 84.6. All right. So step number 1, bring your decimal up. And then I always say, what times 2 gets us the closest to 8 without going over? So it would be 4. 4 times 8 is 8. If I subtract, I get 0, and then I bring the 4 down. So what times 2 gets you the closest to 4 without going over? There's a 2. So 2 times 2 is 4. Then you subtract and bring the 6 down. And then what times 2 gets you the closest to 6 without going over? That'll be a 3. And there it is. It's bigger than the $4.23, which we thought it would be. So it's 42 3/10. So let's look at the next page. Let's play a little bit. So the rules to divide, and remember this is just some bonus. Move the decimal point in the divisor to the right until the divisor is a whole number. Okay, well, this one we don't have to worry about it. It already is a whole number. All right, so we don't have to move the decimal point in the dividend to the same number of places. We'll have to worry about that for this one. So place the decimal point in the quotient directly over the decimal point in the dividend. So let's move up our decimal. So let's go for it. So what times 6 gets us to the closest 57 without going over? Well, 8 times 6 is 48. 9 times 6 is 54, so a 9 is going to work there. And we're going to keep dividing until we don't have a remainder. So I'm going to have to tack on some zeros. So let's bring down this 0. What times 6 gets you the closest to 30 without going over? That's where the multiplication tables come in handy. There you go. So 9.5. All right, let's try it for this one. So 47 divided by 5. Well, I know it doesn't go in evenly, so I'm going to put my decimal, and then you can add zeros if you need to, right? They can't hurt, you may as well. So 5 won't go into 4, so let's not worry about that. So what times 5 gets you the closest to 47 without going over? Well, 9 times 5 is 45, right? Then we subtract, and we bring down the 0. So what times 5 gets you the closest to 20 without going over? It's 4, and then we're done. Okay, let's try this guy. This guy looks harder. So I'm going to set it up, and then we'll rewrite it. So we've got 9.4. This goes on the inside. I screwed it up. Let's bring it down here. 0.94 divided by 2.5. So we're going to have to rewrite this. So you remember, this has to be a whole number. So I'm going to shift this to the right once here. That means this gets shifted to the right once on the inside. Okay? So let's rewrite it. The key thing is this number has to be a whole number. This one doesn't. So I shifted it once to the right, so this gets shifted once to the right, and then bring up the decimal, and then add some zeros if you think you might need them. So I like to think of this in money, like that's a quarter. So 2 quarters is 50 cents, 3 quarters is 75 cents, 4 quarters is $1. So what times 25 gets you the closest to 94? So that's 3 quarters. 3 quarters is 75 cents. And then you subtract. So this 14 minus 5 is 9. 8 minus 7 is 1. We've got to keep going until we get 0. Bring down the 0. So what times 25 gets you the closest to 190? Well, 4 quarters is $1. 5 quarters will be $1.25, or 125 pennies. 6 would be $1.50. 7 would be 175. So I think I'm going to need 7 quarters. And so that'll give me 175. Okay, and then I subtract. Well, I think I'm just about there. And then I bring down the 0. So do you guys agree that 6 quarters will give me $1.50? 4 will give me 100, and 2 more will give me 50. So there we go. So the answer would be 6. And that'll give me 150, and I finally get 0. So that's a kind of bonus that'll be on the test. All right, so let's try this one. Now remember, we did this in the chart, and we got the 3 repeats, so let's see if that makes sense. All right, I don't have to do any decimal shifts, so let's bring up the decimal and then add some zeros if we think we need them. So 3 won't go into 1, but I can think about it going into 10. So what times 3 gets us the closest to 10 without going over? So there's my 3. 3 times 3 is 9, and then I subtract. 10 minus 9 is 1, and then I bring down the 0. So what times 3 gets us the closest to 10 without going over? There's my 3 again, because 3 times 3 is 9. I subtract and bring down the 0. So do you see where it's cyclic? It's just going to keep repeating itself over and over and over. So that's why we use that symbol, and that's the same thing as 1/3. That's something you got to memorize. Definitely want to memorize that. Okay, so it says write the following fractions as a decimal. Do you guys remember what I said 1/4 is? 1/4 is 1/4, so 0.25. So 3 of these quarters would be, just as a little side, 0.75. Okay, let's do 4 out of 20. Now, I would memorize that 1/5 is 0.2. So then 4 of them, well, 2, 4, 6, 8 should equal 0.8. Like you could just, if you just memorize this one, then you should be good with 2/5, 3/5, 4/5. But if you can't remember that and you're on the test or on the final, right, just set up a little division problem. I don't have to do any decimal shifts, but I am going to bring the 0 up, or bring the decimal up and add a 0. So what times 5 gets you the closest to 40 without going over? And there's your 0.8. Right? But if you could just memorize this, then anything with the fifths, then 2/5 would be 2 of those. So that would be 0.2 plus 0.2 is 0.4. See what I'm saying? Like if you memorize this one, and you memorize this one, right, and you memorize this one, any versions of those should be easy to follow. Let's do 4/9. Pop that on there, and I don't know why I thought that was an unusual one. Let's look at that one. So 4 divided by 9, let's bring up the decimal, add some zeros. So what times 9 gets you the closest to 40 without going over? Well, 9 times 4 is 36. So that gets us pretty close without going over. And then if we subtract, oh yeah, look at that. I end up with a 40 again. So what times 9 gets us the closest to 40 without going over? If I put a 4, 9 times 4 is 36, and I subtract, do you see the cyclic again? It's just going to keep repeating. So 4 over 9 is equal to 0.4 repeat. That's an interesting one. That's cool. And then if you check it on your calculator, right, if you put that fraction in and then hit that change key, there's your repeat. You can see it pretty quickly. Okay, the last little bit to this is some shortcut rules for division. Now, this is a review. We've done this already. We did this back in chapter 2. When you divide by a power of 10, do you remember you shift the decimal to the left by the number of zeros? Okay, so the decimal's here. If you can't see it, the decimal's at the very end. So I'm going to shift the decimal to the left 1 place. So I have 3 zeros. So I'm going to shift the decimal to the left 3 places. When you multiply, you shift the decimal to the right. When you divide, you shift the decimal to the left. So I'm going to go to the left 2 places, because there's 2 zeros. Okay? So when you divide by a power of 10, shift the decimal to the left of your dividend by the number of zeros in your power of 10. So get that down, maybe pause the video and see if you can play with those, okay, without your calculator. Okay, so try to do those without your calculator. All right, so if I divide by 10, I'm going to shift the decimal one place to the left. If I divide by 100, and you don't see the decimal, it's right here, we're going to shift it 2 places to the left. This is going to be 3 places to the left. So what do you think you guys would tell me to do with those 2 loops that are there? Oh, I miss seeing you guys. Right? You're going to tell me you would fill them in with zeros, just like with multiplication. So here, multiply means you go to the right. So I'm going to shift my decimal 2 places to the right. Here I'm going to shift my decimal 2 places to the right, and because I'm multiplying by a negative, I'm going to keep my negative. Right? 2 places to the right. So these ones are interesting. I like these because it's going to test you in a couple ways. First of all, PEMDAS says you got to go in order from left to right, and if it's all multiplication and division, you're going to do whatever comes first. So we're going to divide first. So we're going to shift our decimal 1 place to the left because division says shift it to the left. And then what's the multiplication going to say to do? The multiplication says shift it to the right, in this case 3 zeros. So there's your answer, 7.26. There's a lot of decimal dancing going on there. Okay, for this one, you got to multiply first, right? PEMDAS says we multiply before we add. So we're going to shift the decimal 3 places to the right. 1, 2, 3, and plant it. So we're going to have 4.3 plus 2.3. Do you see that? If you need to stack them, go ahead and stack them. But hopefully you guys are going to get 6.6 for that one. Okay, and just as a review, let's pull out your calculator, pause the video, and go ahead and do these 3 questions with your calculator, okay? I showed you where the decimal point was last time. So just pop those in your calculator really fast, and then we'll do them together and make sure you get the same answer. Okay. So 103 6/10 times 7/10. Let's see what you got on your calculator. You guys see that? Let me pull it down here and you can see it. So 103 6/10 times 7/10. Yep. Did you guys get 72.52? All right. For division, I'm just going to stack it. Now, some people's calculators, I don't know if this is one of them, they don't like it when you use decimals in a fraction. So some people might get an error for that. Okay, I did not. I didn't get an error. And did they tell us how to round it? Let's round it to 2 decimals, okay? So we'll round it to 0.11. Okay? Let's round it to 0.11. If they ask you to write it as a, here, let me put this in here. If they ask you to write it as a decimal, then that would have been perfect. If they said write it as a fraction, then it must be able to be written at simplified. So hit that change key. Ah, do you see there's another way to write it? So just be careful on my math lab how they want you to write it. If they say a decimal rounded to a certain number of places, that would have been good. If they said they want it as a fraction, hit that change key so that it rewrites it in a different form, and there's my fraction. If you don't have the change, then you use the F to D key that goes back and forth between a fraction and a decimal. Okay, and so for this one, remember, if we simplify, we want to get rid of the parentheses. So I'm going to take that negative 0.5 and multiply 6.4. So I'm going to get negative 3.2 for my coefficient in front of the y. And then I'm going to take that negative 0.5. And remember, you can't separate the number from the sign. So it's going to be negative 0.5 times negative 7. See how I put that in my calculator? So that new constant is going to be plus 3.5. You just got to be careful of your signs, right? So I'm going to take this 0.8 and multiply it by each term in that expression that follows. So 0.8 times 0.2. So that's going to give me 0.16y plus 0.8 times 0.1 plus 0.08. Okay, so I don't think you'll have too much trouble with the calculator stuff, right? But let me know if your calculator's not working for you. All right, the last little piece to this is some circle work. So let's just review. I know we did this when we were celebrating Pi Day, but let's go ahead and just review this for a little bit. So the radius of a circle is a line segment where you start in the center of the circle and go to any outer edge of that circle. Okay? And a diameter is a line segment that starts at one end of the circle, goes through the center, and then ends up on the other side of the circle. The circumference is a fancy word for perimeter. The circumference is a fancy word for the perimeter. So we can't add up a side because no sides exist. But do you remember we played with the diameter of the circle and we found that we could get 3 full diameters plus a little bit more? So this was the formula that we looked at together. It was pi times d. So if you take a string, right, and wrap it around the circle and open up the string and put it down to a ruler, that's what the perimeter of the circle is. That's the circumference. And here's the fancy formula that we uncovered on Pi Day, if you were there. And then the area is just what the surface is, right? If we cover the entire surface of the circle, and we're going to look at it on the next page, but the formula for area is pi r squared. And I should say where r is the radius, and up here d is the diameter. And if we had been together, I was going to bring in my sticky string again, and we were going to play with the diameter and the circumference and find the circumference of the circle, but we're not together, and I'm so sad about it. All right, so let's look at pi. So pi is a really cool number. It's the first number that we're going to come to that is a decimal that is non-repeating. And it goes on forever and ever and ever. Pi is what is called an irrational number. An irrational number. And an irrational number is a decimal that continues forever, but never repeats. The never repeat part's the key one. Like we looked at 1/3 and it was 0.3333333333, so that repeats. Irrational numbers, look at this. It has no pattern, no repeating numbers or no repeating pattern. And so you can find it on your calculator. There's the calculator, the one I'm looking at, has an actual key that says pi. So if I hit it and hit enter and I don't like that it said pi, again, you just hit the change key and there's the 3.14159, right? On and on and on forever. So just as a little lesson, if I round pi to the nearest whole number, remember I said that's where the Greeks first got their 3. But then they knew it was a little bit more than 3. So if you round it to the nearest tenth, that 4 says keep the 1. If you round it to the nearest hundredth, remember it goes tenths, hundredths, that 1 says keep the 4. And that's typically right there, like when we say pi, most people think 3.14, but it keeps going. So the nearest thousandths would be that 1. And so the 5 would say, make the 1 higher. The nearest 10,000ths, we have tenths, hundredths, thousandths, 10,000ths is that 5. And the 9 says, make it higher. So 3.1416 would be the 10,000ths position. And the 100,000ths would be the 9. So tenths, hundredths, thousandths, 10,000ths, 100,000ths would be the 9, and the 2 says keep the 9. So anyway, just exploring a little bit with pi. So let's play with the circumference, okay? So if this circle shown has a radius of 50, let's draw in the radius. So the radius is 50 feet. The way that the radius and the diameter are related is that the diameter is twice the radius. The diameter is twice the radius. So you need 2 radiuses to make a diameter. So does it make sense that the diameter would be 100 feet then? It would be 50 and then another 50? So when they ask for the exact circumference, they just want you to write the formula down. Circumference is pi d, and then instead of the d, we're going to fill in the 100. That's all. That's the exact. So exact means leave a pi in your answer. Leave pi in your answer. And then to approximate the circumference, they're going to say, okay, let's just, instead of that symbol pi, let's use that it's about, that's what this means. That means about, or really close to, 3.14. And then you can use your shortcut rule and shift the decimal 2 places to the right if you see that. Or let's just go 3.14 times 100. So the circumference, I got 314 feet. So it's about 314 feet. You do not have to memorize these formulas. I will give you that the circumference is equal to pi times the diameter. Okay? So let's practice, but play with area. Now this was an activity we were going to do together. We're not going to do it. It's so sad we're not together with our string and our activity string, but that's okay. I'm going to show you what the formula for area is. It's pi times r squared. So this says the circle shown has a diameter of 40 feet. So let's write the diameter in. So this whole thing is 40 feet, the whole thing. So the radius is half of the diameter. Right? We have to cut the radius in 2 equal parts to get the diameter, or we have to cut the diameter into 2 equal parts to get a radius. So I'm hoping it makes sense that the radius would be 20 feet. So when it says exact, leave pi in your answer. So area is pi r squared, but we do know the radius, so we'll just say it's 20 squared. Area equals pi times 20 squared. Now, when they say approximate, they want you to pull out your calculator. So area is, instead of that pi symbol, we're going to just say it's really close to 3.14, and then the radius is 20. And I'm going to square that. So 3.14 times 20 squared. So it looks like the area is about 1,256. And since it's area, it'll be square feet for the final units on that. All right, let's just practice a little bit. Let's just practice, okay? So I'm going to write the formulas up here. Circumference is pi times the diameter, and area is pi r squared. So why don't you turn off the video. Oh, before we do that, we're not going to round these. So instead of rounding, just use the fact that pi is about 3.14. Okay? They changed the MyMathLab problem, so they just want you to do pi is approximately 3.14. I noticed that with this new version of MyMathLab, they changed that on us. And remember that this symbol here is when we're approximating something. It's really close to it, so that's what that symbol is. So turn off the video and just try this. We'll just practice with this circle that has a radius of 10 feet. So label the radius and then see how you do on these problems. Okay, you can flip back and look at the other ones, but let's just see how you do. Okay, so pause it and give it a try. Okay, so if I have to label the radius of 10 feet, I start in the center and work my way out. So I bet you guys are going to know that these are new vocab words, right, on that final. So the diameter would be 2 of those, so the diameter would be 20 feet. Circumference is pi times d, so the only thing we're going to fill in is the d. You leave the 20 in there, or you leave the pi in there, and we know the units are eventually going to be feet. So now they say approximate it, you pull out your calculator. So we're going to pull out your calculator, and instead of pi, they're going to say use 3.14. And we don't have to round any of these because we're going to get some nice answers. So we're just going to leave it as 62.8. So 62.8 feet. And I'll give you a minute to catch up. I'll show you my calculator again. 3.14 times 20. See if you got that. And then don't forget your units. Right? They're the same units. Okay, and let's do area. You ready? So I'll always give you the formula. Area is pi r squared. So when they say exact, they want you to leave the pi in the answer, and then we can fill in the r. So the radius is 10 squared. And I'll just pop in square feet over here because we'll need that eventually. We'll have to circle that. Excuse me. So find the approximate area. So now you're going to pull out your calculator. We'll fill in 3.14, and then we have the radius squared is 10 squared. All right, so I'm going to just pull out my calculator. So 3.14 times 10 squared. I'm just popping it right into my calculator. I'm not doing anything fancy, just popping that in, and then hit enter. So it looks like the area would cover about 314 square feet. So that's almost like 314 like square tiles, a foot by a foot tiles. So that's pretty big. That's going to cover a big area. All right, so my math lab's open. Give those a try. Let me know if you have any questions. Read the directions to the OWOW very carefully, because I'm going to see all of you at some point over spring break using the Remind or using the Zoom room. Okay, so I will see you all over spring break. You have 2 short videos to follow, and we'll see you soon.